Hi guys, in today's video I'm going to be discussing how we can use calculus to find the area between two curves. This is very important and is always tested in the AP Calculus exam in both AB and BC. So let's see. So this is with respect to the x-axis. So say we have two curves, f of x and g of x. So f of x is something like this. So this is f of x. And g of x is like this. This is g of x. And this point is A on the x-axis. And this point is B. They're asking us to find the area of the shaded region. So this part which I'm drawing lines in, this is the shaded region. So what we do is we know that integral is the area of the curve, right? Integration is the area between the curve and the x-axis. So essentially what we're doing is, so I'll draw it again so that it's easy for us to visualize. So we have f of x like this and g of x is something like this, right? And then we have our 2 points A and B, and we have to find this area. So if we integrate f of x, so this is f of x. So if we integrate f of x between A to B, we get this complete area, right? So between the curve and the x-axis, so this entire thing. This part which I'm highlighting in red. So this is what happens when you integrate f of x with respect to A and B. However, we're getting an extra part here, right? We only want to find this part. However, we're finding this part as well. So what we do is we find this and subtract it by the area of, I'll use a different color, of the part in pink. So the area of the red minus the area of the part in pink will give us the area of the part in blue. So what is the area of the part in pink? That would be the integral A to B. So this g of x, right? G of x dx. And the area of the part in red would be integral A to B f of x dx. So now we know we subtract the red and pink. So the area of the shaded region in blue would be integral A to B f of x minus g of x. So now let's look at another example so that it's clear. But this time, let's look at it with respect to the y-axis. So we have a graph. This is g of y, so with respect to the y-axis. And then we have another graph which goes like this. And this is f of y. And this point is A, where the graphs intersect, and this point is B. They're asking us to find the area of the shaded region in blue. So this region. So we saw that in when it was in respect to the y-axis, it's always the upper function minus the lower function. When it's in respect with respect to the y-axis, it's always the function on the right. So it's always right minus left. So which function is on the right now? Like within these two bounds. You can see g of y goes all the way here. However, f of y stays here. So f of y is to the right. So it would be integral a to b f of y minus g of y dy. And now they will give us values in the question. If you plug it in and evaluate the integral, we'll get our value for the area. So now let's look at a question. So they've in this question, they've given us values, so we have to find out the answer. So this is our plane. And we have a downward facing parabola here. And a straight line. So this is y equals negative x plus 1. This is our first function. And the second function is y is equal to 3 minus x squared. So these are our two graphs. And they're asking us to find the area bounded by the two graphs. So what does that mean? We have to find the area in which these two graphs form a certain place. So between the two bounds or the points where they intersect, this is the closed area. So we have to find the area of this blue region. So what can we do? So how do we first find the bounds now? That is our first step. Our first step is to find the bounds. So what we do is we have to find this value and this value. We can see that those are the values where the graphs intersect. Hence, we equate our two equations. So 3 minus x squared is equal to negative x plus 1. And if we solve this out, we get x is equal to 2 and x is equal to minus 1. So these are our 2 points where they intersect, which are our two bounds. So then the integral would be negative 1 to 2, the upper function minus the lower function. You can see between these two bounds, the parabola is above the straight line. So it would be 3 minus x squared minus x plus 1. This would be integral minus 1 to 2, 3 minus x squared plus x minus 1. And now we can evaluate this integral and find the value. So that's how easy it is. Okay, that's it for today's video, guys. In today's video, I introduced how to find the area between two curves with respect to the x-axis and the y-axis. Thank you. Hope you have a great day and please consider liking and subscribing.